If an investor holds a bond until its maturity, the rate of return that they've earned is called the yield to maturity. Since the maturity payment and the coupon payments don't change once the bond has been issued, which is why we call bonds fixed income securities, we will assume that the yield to maturity is always equal to the investor's required rate of return. The yield to maturity can be broken up into two components, the expected current yield plus the expected capital gains yield. The expected current yield is, by definition, the coupon payment divided by the beginning price. The expected capital gains yield is the change in price divided by the beginning price. And so since it's the change in price, we need to know what period of time we're talking about when we're calculating a capital gains yield. Is it the yield over the first period, over the first two periods, or over the entire life of the bond, etc.? So let's look at an example and calculate both of these yields. Suppose a 6-year bond has a current price of $1,043.55 and pays an annual coupon of 11%. If the bond has a par value of $1,000, find the yield to maturity, the current yield, and the capital gains yield over the next period. First, let's find the yield to maturity. The annual payment is the coupon rate of 11% times the par value of the bond, $1,000, or $110. So we enter this in as the payment. The number of years is 6, and since each period here is 1 year, we just enter in 6 for the number of periods. The current price of the bond is $1,043.55, so we enter this in as a negative number for present value since this is what we're willing to pay today for the bond. It would be a cash outflow for us if we were to buy the bond. The par value is $1,000, so we enter that in as a positive value for future value since we'll be receiving this 6 years from now when the bond matures. It's a cash inflow to us. We can now solve for the yield to maturity by pressing the interest rate button, and we see that it's 10%. Recall the definition of the current yield. It's the coupon payment divided by the beginning price. Well, we found the coupon payment to be $110. And the beginning price of the bond was $1,043.55. So we can find the expected current yield. It's the $110 coupon payment divided by the current price of $1,043.55, and we see that the current yield is 10.54%. Now let's find the capital gains yield over the next period. Remember the definition. It's the change in price divided by the beginning price. To find the change in price, we need to find what the bond will be worth 1 period from now. Well, 1 period from now, there will be 5 years left until maturity, so we enter in 5 for the number of periods. The coupon payments will still be $110, the par value is still $1,000, and the yield to maturity is still 10%. We can now solve for the current price of the bond. It's going to be negative $1,037.91, and that's negative again because that's what we're willing to pay a year from now. So that's the price of the bond 1 year from now. So what is the change in price over the first period? Well, it's just the difference between the price 1 year from now and the price today. So it's the $1,037.91 minus the $1,043.55, which gives us a change in price of negative $5.64. So now we can calculate the capital gains yield. It's the change in price divided by the beginning price. We found the change in price to be negative 5.64 and the beginning price to be 1,043.55. So we see the capital gains yield is negative 0.54%. To check our numbers, we can see if the current yield and the capital gains yield add up to the yield to maturity, because again, by definition, the yield to maturity is equal to the current yield plus the capital gains yield. We found the yield to maturity to be 10%, the current yield to be 10.54%, and the capital gains yield to be minus 0.54%. So when we add those two together, we do indeed get back the yield to maturity of 10%. In our example, we saw that the current price of the bond was higher than the par value. Remember, this is because the discount rate was lower than the coupon rate. We say bonds that have a current price higher than their par value sell at a premium. This should make sense since the investor is effectively getting a higher interest rate from the coupon payments than his required rate of return, and thus he pays a premium for it. Similarly, if the discount rate on a bond were higher than the coupon rate, the price of the bond would be lower than the par value. We say bonds like this sell at a discount. This is because the investor is effectively getting a lower interest rate from the coupon payments than his required rate of return.